In this lesson, we're going to learn about similar figures, and to do that, we're going to be able to, at the end of this video, be able to determine if two polygons are similar. We're going to be able to calculate a missing side length and be able to calculate a missing angle measure in similar polygons. So before we get there, we got to learn what similar polygons actually are. And as you see here, those are polygons with corresponding angles that are congruent. And I'm going to talk about corresponding here in just a little bit, but first I want to talk about this congruent part. So this word right here is just a fancy way of saying that the measures are equal. There we go. Okay. So don't let that one scare you there. It's just a fancy math term. So in other words, we have corresponding angles that are equal in measure, or their measures are equal. The second part of that is the corresponding sides have to be proportional, and we'll take a look at that as well. So in my two polygons I have here, I want to show you why they're actually similar. So I start with the corresponding angles being congruent. Now the way that we figure that out is we take a look at all of these angles. So I'm going to start with angle J. Now I notice in angle J in here, it has these three little arcs in there. So when I come over here, I have to find an angle that has three arcs in it as well. So, and that one doesn't show up as well. I'll just circle it temporarily. This one right here. Okay? So that has the three arcs that are congruent. So we know that those two angles would have to match up. So then what I'm going to do here is I'm going to say that angle angle J and angle U, those are our congruent angles. And this is the fancy little term for congruent. It looks like an equal sign with a little squiggle on top of it. And then I'm going to go on to my next angle from the figure on the left. That's angle K. So now I have angle K. Well, which one does angle K match up with? Well, I notice angle K has the two arcs. So I'll come over here, and angle T has the two arcs on the other one. So angle K and angle T are the congruent angles. So far it's looking pretty good. Then I'm going to go down, or keep going around to get a little more space here. So now I'm on to angle L. Well, angle L, we notice, has the single arc up here. So I come over here, find the angle with the single arc. That's angle S right there. So angle L and angle S are the congruent angles. And last but not least, I have angle M over here. Notice it has the four arcs in it. I'll come over to the quadrilateral over here, and I notice, well, that's angle R. So I know angle M and angle R are my congruent angles. So I look at this and I go, I have four angles from my quadrilateral on the left being congruent to four angles from my quadrilateral on to the right. I know that I have satisfied this first statement that says the corresponding angles are going to be congruent. Now I go on to the next part where we look at the corresponding sides being proportional. I'm just going to take this stuff and just slide it over a little bit. There we go. All right. So now I go corresponding sides. So I'm just going to start with any side from my quadrilateral on the left. And for me, I'm going to start with that short side that is 12 units long. Now that's side MJ. So I'm going to just go side MJ, notice is 12 units long. And then we have to find that same corresponding side on the other one. Well, what we look for is, I notice that side MJ is the side that's between the four arced angle and the three arced angle. So I'll come over here and go, oh, there's the four arc, there's the three arc. Which is the side in between those two? Well, it's the side that's 3 units long. So when it's talking about being proportional, I'm thinking fractions. So I'd go 3. So I have my 12 over 3 when I'm looking at my corresponding sides that have to be proportional. I put my corresponding sides together into a fraction. And then I go to my next one. So now I'm going to go to my side that's 17 long. I'm going to write another proportion. So now I got 17. Well, that has to be over, that's the side that's between the 2 arc and the 3 arc. So I come over here and notice that my 4.25 is the one that's between the 4 arc, or the 3 arc and the 2 arc. So 4.25. my fraction. I continue around. Now I have the 26 side. Well, the 26 side is between the single arc and the double arc. Come over to my quad on the right, and between the single and the double arc angle is the 6.5. So I'm going to have my 6.5. And then last but not least, we have the 20. Side that's 20, well, that's between the 4-arced angle and the single arced angle, and this one is the 5. So now I have these 4 ratios, but if these quadrilaterals are really going to be similar, those ratios have to be equal. That's the proportional part, ratios that are equal. Well, if I go through and I simplify each one of these, 12 over 3, that's the same thing as 4. 17 over 4.25, that also equals 4. 26 over 6.5, 4 again, and 20 over 5 is 4. All 4 of my ratios are equal. That means that my sides are proportional. So we had all of our angles, corresponding angles being congruent, and here, whoops, here we have all of our sides being proportional. Therefore, we know that our 2 quadrilaterals are similar. Now, I want to write a similarity statement here. So what I can do then is, I'm going to go write down quad. I'm going to abbreviate this, quadrilateral, and now I'm just going to, it doesn't really matter what order I go in as long as I go in consecutive order. So I'm going to go quadrilateral J, K, L, M. As you can see up here, that's what I have. Now, this is the important part. When we write quadrilateral for the other one, we have to do it in that same order. So we have to look at J. Angle J from the quadrilateral on the left matched up with which angle from the quadrilateral on the right? Well, that was the U. And then we have to go to the K. K matched up with which one? K matched up with angle T. Guess that didn't show up very well, did it? Because we have the double arcs. Then we go to angle L. Well, angle L was the single arced angle. That was angle S. So we go with the S. And then last but not least, the only one left is M. Angle M had to match up with angle R. Oops, I wanted to have this be a different color. I wanted this to match the other one, so that would be green. Let's go like that. So now we have quadrilateral JKLM is similar to, and the fancy little symbol that we put in here is just like that. That says similar to quadrilateral UTSR. Now, the next thing that I want to look at is I want us to be able to calculate the measure of a missing angle measure. In this case, there's 3 of them that are missing. The only one that I really want to focus on is angle Y. I want to know what's the measure of that one. Well, if we go back, I'm just going to come back here real quick, and we look at this, that the corresponding angles are congruent. Well, I just have to figure out which angle corresponds to angle Y. And the piece that I'm going to look at here is, I'm going to go back to that similarity statement right here, where it tells us triangle ABC is similar to triangle XYZ. Well, angle Y from our triangle on the right is going to have to pair up with angle B from our triangle on the left. So I just come over here, I look at angle B. Angle B is 115 degrees, therefore angle Y also has to be 115 degrees. Now in this one, I have 2 parallelograms that are similar. And this time I want to know what's the length of the side that's marked W. So we can see that right here. I need to figure out how long is that. Well, I'm going to go back 2 slides. And now in this one, look at the orange where it says corresponding sides are proportional. So we come back here, and if my corresponding sides are proportional, I think in my head, I need to set up a proportion. And remember what we did with when we were trying to figure out if our, or trying to show that those 2 quadrilaterals in the first one were similar? I set up ratios with all the corresponding sides. And what I like to do, if I'm trying to figure out what W is, that's the piece that I always start with. So I start with this W. And I go, well, which side corresponds to the W? And I look at this parallelogram here, and I go, well, W is the longer of the 2 sides. And if these are going to be similar, which they are, it says that, that's going to have to match up with the longer side in the other one, which is the 21. So I'm going to write a ratio of W over 21. And then I'm going to have another ratio, and this one's going to have a couple other side lengths. So I go back to my original, or not the original, the first parallelogram that I worked with, and then when I say first, because W was on top, so then I got to find another side in that one, which is 15. Now, which one does the 15 match up with? 15 is the short side, 6 is the short side in the other one, so then I have that ratio right there. And since we're setting up a proportion, these two ratios have to be equal to each other. So to find the length of that missing side, now it's just a matter of solving this proportion. Just move this up a little bit. So what I do when I solve my proportions, I cross multiply. So when I cross multiply there, I'm going to get 6W. If I cross multiply this way, we get 315, and those are equal. And now we have to divide both sides by 6. And we find out that W equals 52.5. I come back up here and look to see if I need a label, but there was no label here, so if I wanted, I could put units on there. And we just figured out the missing side in our parallelogram. Now, there are two tests that we're going to take a look at to figure out if triangles, now this is focusing only on triangles, not polygons in general, triangles, if triangles are similar or not. We don't have to go through that full-blown test of checking all three angles to make sure that they are congruent to the three angles in another one, and to make sure that all three sides are proportional. So in this first one, it's called the AA Similarity Theorem, and all we have to do is, it says that if the angles of one triangle and the corresponding angles of a second triangle have equal measures, then the triangles are similar. Now, it does say if the angles, so all of them, but really we only have to check two of them. So I look at this and go, well, I have one angle here being congruent to one angle here, and then I have a second angle here being congruent to a second angle here. So this tells me that yes, these two triangles are similar. So I'm just going to put the big similar symbol in between them to tell me that those two triangles are similar. I don't have to look at anything else. If those two things happen, those triangles are similar. And then I have the other one that says if the measures of the two triangles, if the measures of the sides of two triangles form equal ratios, in other words, are proportional, then our triangles are similar. So when I look at this one, I look at setting up those ratios. Well, we have a side that's 6, which is the shortest side. That's going to have to match up with the shortest side on the other one, which would be 2. I have a side that's 9, and I'm going to call that the middle side. Well, that would have to match up with the middle side on the other one, which is 3. And then we have the longest side, which is 12. And that's going to have to match up with the longest side, which is 4. Now, are those ratios actually equal to each other? Well, that's where I go through and I simplify. That equals 3, that equals 3, and that equals 3. So yes, my three sides are proportional, which tells us that those triangles are similar. So kind of the quick checks, we don't have to look at everything. So then I come here and I go, well, are these two triangles similar? And I'm looking, I just have angles. I know nothing about side lengths, which I don't have to. But now I think back and go, well, if I had two angles from the triangle on the left being congruent to two angles from the triangle on the right, I'd be good to go. I'm missing an angle. So we could go through and we could figure out the measure of this angle, but I look at it and go, we don't need to. Because 60-degree angle. Now, maybe this one's a 60-degree angle. You'd actually find out it's not, but maybe it was. But then I'd have this second 60-degree angle, which is not going to match up with either one of these. Therefore, I know, without going any farther, that these two triangles are not similar. So I'm just going to write, no, they are not. And I erased the 60-degree angle that I had in the top right corner here because this one is not a 60-degree angle. I'll show you how to find a missing angle in this example here, because I'm going to look at this and ask, are these two triangles similar? Well, this one I look at and go, I already have one set of congruent angles. It's right here. Those are both 89 degrees. But I need that second set. Well, I look at it and go, if if I look at the 52-degree angle, well, that obviously doesn't match up with a 39, but does it match up with this angle here? I don't know. So what I'm going to do is I'm going to try to figure out what is the measure of that angle in this triangle. Well, I think back and go, well, if I add up the three angles in a triangle, it always adds up to 180 degrees. So what I'm going to do is I'm going to take 180 degrees, what it all has to add up to, and then I'm going to subtract the one angle that or the two angles that I know. So I'm going to subtract the 89-degree angle, and I'm going to subtract the 39-degree angle, because that should leave me with the measure of this one. So what I like to do is I'm going to change this a little bit. I'm going to take and look at it as 180 minus, I'm going to add these two angles together first. It's the same thing. It works out a little easier in my head. So if I take the 89 and the 39 and I add those two together, I end up with 128 degrees. And then I still have to take the 180 and subtract that. And if I take 180 minus 28, we end up with, we'll stick with the red then. That turns out to be a 52-degree angle. So this angle right here that I had marked as a star turns out to be at 52 degrees. So we just figured this one out. Now I look at it and go, well, I have a 52-degree angle over here. And then we just figured out that that's also a 52-degree angle. So are these two triangles similar? Yes, they are, because we showed that we have two sets of corresponding congruent angles. Therefore, we know that our triangles are similar. I could put the big similar symbol between them to let me know. And then I have one more here. This one, we know all the sides in our triangles. So I think back and go, well, now I'm going to use that other shortcut that said if all the sides are proportional, we would know that our triangles are similar. So what I'm going to do on this one is I'm just going to set up three ratios with my three sides. So I'm going to start with the short side over here, which is 4. I'm going to have to match that up with the short side over here, which is going to be the 2√3. Then I'm going to go to my medium side for both triangles. That's going to be the 4√3. And then that will be the 6 on this one. And then we'll go to our long side, which is 8 and 4√3. Now when we look at these are a little harder to tell if they're actually the same or equal. So I guess one way to do it is we could go through and we could simplify it. You know what? I think it's not going to matter. We're going to simplify these. So think back to simplifying our radical expressions. For this one, we have to multiply numerator and denominator by √3. I'm also going to look at this. This 2 is going to become 1, and this 4 is going to become 2. So my numerator now is 2√3, and my denominator comes out to be 3. On this one, we can just simplify the 4 and the 6. 4 is going to become 2, 6 is going to become 3, and we end up with 2√3 over 3. Those are the same, so that looks good. And then last but not least, on this one, we're going to have to multiply by √3 over √3. This 4 is going to become 1, that 8 is going to become 2, and we end up with 2√3 over 3, which is equal. So are these triangles similar? The answer is yes, because all three sets of sides are proportional. All right. Yes, and we could put the big similarity symbol between them just to remind us. And that is going to conclude our lesson on similar figures.